Let's learn about trig integrals. Now there are so many cases for these, but I'm going to make this as easy as possible. We're going to start with cosine cubed sine x, and then I've got two other examples for you. The sine to the fourth of x is going to be covered in another video where I will do even powers of sine and cosine. Let's go ahead and dive in with this first one. When you're working with a trig integral like this one, you're going to be working towards a u-substitution. So we're going to start by deciding what du is going to be. I'm going to go over here to my derivatives of trig functions. It's important that you know these really well because all of these derivatives are candidates for our du. I'm going to run through this list, and it looks like what I've got as a candidate is negative sine of x. So let me go ahead and undo this. In my integral, though, I just have the sine of x. So we're going to let du be that sine of x, but there is a negative sign in here. So let's go ahead and formally do our u-substitution assignments. U then needs to be cosine of x because that's going to get me to the du that I chose. I take the derivative of cosine, I get a negative sine x dx. I'm going to bring the negative sign to the other side, so I've got exactly what I want to replace, and that's the sine x dx. Now I can go ahead and replace du right here. So this is going to get a negative du, but I also need to work with that cosine cubed. U is equal to cosine, so that means that this cosine cubed is going to be a u cubed. Let's do our u substitution. So equals, in terms of u, the integral of cosine cubed. Cosine is u, so that's going to be u cubed. And then our sine x dx is replaced with a negative du. Working through this one, I can pull the negative sign out in front, and I'm going to end up integrating u cubed du. This is going to give us negative, that power goes up to 4, so u to the fourth divided by 4. This is indefinite, so I need that plus c. And I'm going to go back to an x, taking that definition of u. Let's go ahead and replace u with cosine of x. So I get negative cosine to the fourth of x divided by 4 plus c. In this next one, I've got the integral of tan to the fifth 3x, secant squared 3x. The very first thing that I want to determine is what my du is going to be. So over here to our derivatives, I can choose anything from either of these columns of derivatives. And I notice that I actually do have a secant squared as one of our derivatives. So that's going to become our du. Now there's going to be a little more involved because I've got that 3x in there, so let's go ahead and do the formal u substitution. If du is going to be that secant squared, that means that u is going to be the tan x. Look how nicely that's going to work for our function here. So I've got the tan of x, and I really need it to be the tan of 3x since that's my argument. Du then is going to be secant squared 3x. I'm going to use a chain rule here. I need to multiply that by the derivative of the inner function. That's going to be a 3, and then I'll put that dx on the end. But what I'm substituting is the secant squared 3x dx. Let's go ahead and divide both sides here by a 3. So du divided by 3 is equal to secant squared 3x dx, and that's exactly what I need to replace up in my integral. Now I also need to replace the tan to the fifth. So as I'm thinking about replacing that tan to the fifth, I've got that u is equal to tangent. So this is going to become u to the fifth. Let's go ahead and do that substitution. As I do my u substitution, I get the integral of tangent to the fifth, but u is tangent, so that's going to be u to the fifth. And then that secant squared 3x gets replaced by a du divided by 3. So du, that's supposed to be a u, du divided by 3. I can think of that divided by 3 as a 1/3. So let's go ahead and bring that out in front. So I get a 1/3 integral u to the fifth du. What a nice integral we end up with here. As I finish this one off, I can go ahead and take the integral. I have my 1/3 out in front. U to the fifth's power is going to go to the sixth. So I get u to the sixth divided by 6 plus a c. That's going to be u to the sixth divided by 18 plus c. One more step. I need this to be in terms of x, and I know that u is my tan 3x. So I end up with u to the sixth. That's going to be tangent. Let me get rid of that. That's going to be tan to the sixth 3x, all divided by 18 plus a c. In this one, I just have an odd power of cosine. I've just got cosine to the fifth. I still need to use the derivatives from my list of trig derivatives to determine what du is going to be. So as I'm looking at that list, it doesn't leave me with a lot of options except for that cosine. That's all I've really got to work with there. So I'm going to have cosine x be my du. So this means that u then needs to be the sine of x. And du gives us exactly what we were working for, which is the cosine of x dx. So you can see that I've got some work to do with my integrand. I need a sine in there along with that cosine. Let's go ahead and start by isolating that cosine of x. So I'm going to rewrite this as the integral of, if I pull one cosine out to be my du out of the 5, that leaves me with 4. So I've got cosine to the fourth x times cosine x dx. And that cosine x dx is our du. Now I've got to get that cosine to the fourth in terms of sine, so it works with my u substitution. This is where I'm going to need my Pythagorean identities. I know that sine squared plus cosine squared is equal to 1. I need what's left to be in terms of sine. So if I rewrite this one, I'm going to manipulate it because I can only rewrite cosine squared using a Pythagorean identity, not cosine to the fourth. So continuing to work with these properties of exponents, this becomes cosine squared x all squared. There's my cosine to the fourth. And then I'm separating out still that cosine x dx to be my du. Now I can work with sine squared plus cosine squared equals 1. So I've got sine squared plus cosine squared equals 1. I need to solve cosine squared in terms of sine. So I'm going to subtract that sine squared from both sides. And I have that cosine squared is equal to 1 minus sine squared. Now I'm getting somewhere. So in this integral, I can write what's inside the parentheses as 1 minus sine squared x. That was still all squared. And then I've got this as cosine x dx. Now that I've got everything in terms of sine for that set of parentheses and then the cosine, which is going to be my du, I'm ready for my u substitution. U was the sine of x, so here I really have a 1 minus u squared in the parentheses. Let's go ahead and do that u substitution. So in terms of u, this is equal to, in terms of u, the integral of 1 minus sine squared, but sine is u. So that's going to be u squared all squared. And then I've got my cosine x dx. This is du. Remember, this is where we started. Now, in order to integrate this, I need to expand that 1 minus u squared all squared using FOIL. So this really is parenthesis 1 minus u squared, 1 minus u squared, and then that du. Let me move this up further so I've got a little bit more room. We're almost to our answer. We're actually to the easier part now. Let's go ahead and FOIL what we've got there in yellow. So foiling what I've got in yellow, I've got 1 times 1. And then I've got minus u squared minus another u squared. That's minus 2u squared. And on the end, I've got a negative times a negative. So plus u to the fourth. And then we had our du. I'm ready to integrate using a power rule. So as I integrate, I end up with the integral of 1 is u minus 2. The integral of u squared is u cubed divided by 3. And the integral of u to the 4th is u to the 5th divided by 5 plus c. Just one more step, and that's to go back to x's. So rewriting this in terms of x, I've got u, which is the sine of x, minus 2u cubed, so that's going to be the sine cubed of x, all divided by 3, plus u to the 5th, that's going to be sine to the 5th x divided by 5 plus c, and we've got our answer. The next example is going to be the integral of cosine to the 4th dx. I'm going to cover that in the next video as we work through even powers of both cosine and sine. You got this. Thank you so much for watching.